Now the part number 10, x raised to the power 3 by 2. Almost the same questions, same part discussed in our previous parts. So I think this is an easy exercise. You can simplify it yourself. Delta y and x as a common factor, 1 plus delta x over x raised to the power 3 by 2. Just put the value of this y. X 3 by 2 will become a common factor. We have 1 plus delta x over x 3 by 2 minus 1. Applying the binomial series here, you must check it yourself. Simplifying 1 and minus 1 will be cancelled out. Dividing both sides by delta x, delta y by delta x, x raised to the power 3 by 2 minus 1 and delta x by delta x will be cancelled out. So delta y by delta x is equal to x raised to the power 1 by 2. The bracket portion will remain same. Taking limit delta x approaches to 0 on both sides. So limit delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0, applying limit on right hand side. So all the terms containing delta x will become 0 except this first term, which is 3 by 2. Left side will become dy by dx and right side will be 3 by 2 into x raised to the power 1 by 2, which is actually differentiation of the given function. Y was actually x raised to the power 3 by 2 and 3 by 2. This can be written as square root x, because if a function containing a power 1 by 2 can be written as a square root. So we have 3 by 2 into square root x. X raised to the power 5 by 2. Almost the same question. Just simplify in the part 10. 3 by 2 now with power 5 by 2. Y is equal to x raised to the power 5 by 2. First step was y plus delta y and x plus delta x raised to the power 5 by 2. Delta y will become x plus delta x raised to the power 5 by 2 minus y. Put the value of y and applying to convert this function into a binomial series form. So and then apply binomial series 1 plus delta nx. Here n is 5 by 2, x is delta x over x, n into n minus 1 2 factorial x square up to so on, and this minus 1 will remain same at the end. Sorry, this one is actually a missing x raised to the power 5 by 2. X raised to the power 5 by 2. This x raised to the power 5 by 2, which is actually missing in this step. This one. So delta y is equal to x raised to the power 5 by 2, which is this one. And delta x over x as a common factor, and we have only 5 by 2. After cancellation this 1 and minus 1, we have 5 by 2 plus this will become a common factor, and 5 by 2 minus 1 2 factorial delta x over x and up to so on. Dividing both sides by delta x, just division by delta x, this will be cancelled out. Delta y by delta x will become x raised to the power 3 by 2. After simplification this 5 by 2 minus 1 by taking an LCM, and this bracket portion will remain same. Taking limit delta x approaches to 0, applying limit on both sides. So left side will become dy by dx, and when we apply limit delta x approaches to 0 on right side, again the same process, all the terms will become 0 due to the presence of this delta x, except this first term, which is 5 by 2. Multiplying to x raised to the power 3 by 2, we have 5 by 2 x raised to the power 3 by 2, which is actually differentiation of the given function and can be written as d by dx. Just put the value of y, which is x raised to the power 5 by 2, and right side will become 5 by 2 x raised to the power 3 by 2. Part 12, x raised to the power m. Solution: let y is equal to x raised to the power m. Y plus delta y is equal to x plus delta x raised to the power m. So delta y is equal to x into 1 plus delta x over x raised to the power m minus y. Now put the value of y, which is x raised to the power m, and from here x raised to the power m can be taken as a common factor, and we have 1 plus delta x over x. So delta y, by taking x raised to the power m as a common term from whole these two terms, and then apply binomial series 1 plus nx, n is m and x is delta x over x, plus n into n minus 1 2 factorial and x square delta x over x whole square up to so on. this minus 1 will be at the end. This 1 and minus 1 will be cancelled out. This delta x over x will become a common factor. We have only m plus m into m minus 1 2 factorial delta x over x and up to so on. Dividing both sides by delta x, we have delta y by delta x is equal to x raised to the power m minus 1 delta x over x. This bracket portion will remain same. Now delta x over delta x will be cancelled out. We have only delta y by delta x is equal to x raised to the power m minus 1 into m plus m minus 1 2 factorial delta x over x plus up to so on. Taking limit on both sides, delta x approaches to 0. So just apply the limit, delta x approaches to 0. Left side will become dy by dx, and on right side, all the terms containing delta x will become 0 except this first term, which is m. So finally we have derivative of x raised to the power m is equal to m into x raised to the power m minus 1. Now 13th part, 1 over x raised to the power m, almost the same case, just y will become x raised to the power minus m. 1 over xm can be written as x raised to the power minus m. So y plus delta y is equal to x plus delta x raised to the power minus m. Delta y is equal to x into 1 plus delta x over x raised to the power minus m minus y. From here x can be taken as a common factor. So 1 plus delta x over x. So delta y is equal to x raised to the power minus m into 1 plus delta x over x raised to the power minus m minus x raised to the power minus m. Now x raised to the power minus m can be taken as a common factor. So we have x raised to the power minus m and 1 plus delta x over x raised to the power minus m minus 1. Now apply binomial series here. We have delta y is equal to x raised to the power minus m into 1 plus nx n into n minus 1 2 factorial x square. So n is minus m and x is delta x over x. That will become minus m into delta x over x, and from here minus m minus 1 2 factorial x square, which is delta x over x whole square. This plus 1 and minus 1 will become cancel out, and delta x over x as a common term, we have delta y is equal to x raised to the power minus m delta x over x, and from here we have minus m plus minus m minus 1 2 factorial and delta x over x raised to the power 1 and up to so on. Dividing both sides by delta x, delta y by delta x is equal to x raised to the power minus m minus 1 delta x over x delta x into a bracket portion. Delta y by delta x is equal to x raised to the power minus m minus 1 minus m plus minus m minus 1 2 factorial delta x over x plus up to so on. Now applying limit on both sides, delta x approaches to 0. So delta y, limit delta x approaches to 0, delta y by delta x, and on right side applying limit delta x approaches to 0, x raised to the power minus m minus 1, and this one is again the same thing in bracket portion. Left side will become dy by dx, and on right side applying limit all the terms will become 0. We have only this minus m, and finally derivative of 1 over x raised to the power m will become minus m into x raised to the power minus m minus 1. 14th part, x raised to the power 40, a positive integer actually. Let y is equal to x raised to the power 40. Y plus delta y is equal to x plus delta x raised to the power 40, and delta y is equal to x into 1 plus delta x over x raised to the power 40 minus y. So delta y is equal to x raised to the power 40 1 plus delta x over x raised to the power 40 minus, just put the value of this y, which is x raised to the power 40. Now delta y is equal to x raised to the power 40, taking as a common factor from both these two terms, we have 1 plus delta x over x raised to the power 40 minus 1. Applying binomial series here, delta y is equal to x raised to the power 40 1 plus nx 40 into delta x over x plus 40 into 40 minus 1 2 factorial delta x over x whole square up to so on, and at the end minus 1. Now just a small change in this particular step. We have a function containing a positive integer as a power, but we already discussed that, or already know in our first year course, that if this power is a negative integer or a fraction, then that will become an infinite series. And if this one is a positive integer, then that will not be an infinite series. That must be must contain and n term. So by using this rule, we have 1 plus nx plus n into n minus 1 2 factorial x square up to so on, and at the end we have this last term, which is delta x over x raised to the power 40. This is the only difference from all other parts due to this positive power, and at the end this minus 1 will remain same. So this one is the only difference, and you people can must note this step, that you must write an n term here, and almost all the steps become the same thing. Delta y is equal to x raised to the power 40 by cancelling this 1 and minus 1 and taking delta x over x as a common factor. We have 40 plus 40 into 40 minus 1 2 factorial delta x over x and up to so on, and at the end we have delta x over x raised to the power 39. Dividing both sides by delta x, delta y by delta x is equal to x raised to the power 40 minus 1 delta x over x into 40 plus 40 into 40 minus 1 2 factorial delta x over x, and at the end delta x over x raised to the power 39. So delta y by delta x is equal to x raised to the power 39. This will be cancelled out. We have 40 plus 40 into 40 minus 1 2 factorial delta x over x, and at the end we have delta x over x raised to the power 39. Now applying limit on both sides, delta x approaches to 0. So limit delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0, x raised to the power 39, and all the portion will remain same with an addition of this delta x over x raised to the power 39. So left side will become dy by dx, and applying limit on right side, all the terms containing this delta x, which will become 0 except this first term. So we have only this 40 multiplying by x raised to the power 39, which will become actually derivative of the given function, which is x raised to the power 40. And d by dx, y will become x raised to the power 40 is equal to 40 into x raised to the power 39.